In this example, we're asked to solve a logarithmic equation. And to do so, we may need to use properties of logarithms. And that is the case for this first problem. So one of those properties allows us to condense this logarithm like so, multiplying the x plus 10 times x plus 2. And I'm going to finish that out, still equals 2. At that point, since I have just one logarithmic expression equal to a constant, I can change this now to an exponential form. The base is 3. The log always equals the exponent, so the exponent is 2. And that is set equal to this expression, x plus 10 times x plus 2. So let's multiply some things out. That's going to give us 9 on this side. Here, when we multiply this out, we get x squared plus 2x plus 10x plus 20, which we can combine some like terms to the following. Oops, forgot my x. And because this equation is now quadratic, we're going to use quadratic methods to solve. The quadratic method, or most quadratic methods, start with setting the equation equal to 0, meaning I need to subtract 9 from both sides. So if I subtract 9 from both sides, meaning this constant over here in particular, I'm going to have the following equation. Now, that equation I need to either solve through factoring, if I can factor. Perhaps I can graph and look for x-intercepts, if I can. I can always do quadratic formula, and I can always do completing the square. So it's really up to you as far as what choice you want to make there at that point. So because I'm looking at this equation and realizing now that it can factor, I'm just going to rewrite it up here. I'm going to go ahead and factor it. So two numbers whose product is 11 and whose sum is 12 will be 11 and 1. We set each of these factors equal to 0. That's that 0 product property that we learned in the quadratics unit. And then we solve each of those smaller equations and we get these two answers. X is negative 11 and negative 1. However, this original problem was a logarithmic problem or equation. So one of the things we must do is after we solve, we must go back and substitute our solutions to see if they really are solutions in the logarithmic equation. So if we were to come over here and let x equal negative 11, let's say, negative 11 plus 10 becomes negative 1, and we cannot take the log of a negative number. So negative 11 is out. When we try to test negative 1, let's try that one. I'm going to actually go through the whole process over here. So let's try negative 1. And let's see if this really is true. We get the log base 3 of 9 plus the log base 3 of 1 equals 2. Well, the log base 3 of 9 is a question that says what exponent needs to be on the base 3 in order to get an answer of 9. Well, the exponent needs to be 2. 3 squared is 9. So that gives us a value of 2. Log base 3 of 1, the question that's asking you to solve is what does the exponent need to be on the base 3 in order to have an answer of 1? Well, 3 to the 0 power equals 1. And that checks. So we will keep only this solution and we will throw away this extraneous solution.